So on 18th of March 2022, Google Maps had a major global outage that lasted for over 2.5 hours. This is the incident report of it, and in this video we will dissect this particular outage, and as an outcome of this we'll understand how to design a robust microservices based architecture. Right? So let's jump right into the issue. What happened is on 18th of March, Google Maps platform API experienced elevated error rates, which basically means in terms of HTTP request a lot of 5x6. And the APIs that were included was Google Maps JavaScript API, Static API, Android, iOS, Navigation, SDK, Gaming Services. So typically everything around Google Maps was down for that 2.5 hours. The main culprit or the main thing that got impacted was the Maps Tile API was impacted for over 3 hours and 45 minutes. So Tile API renders the tile on your Google Map which has this rich information. So that tile was not rendering, which means that what did your end user see during this outage? Your end user during this outage saw what? They saw gray tiles, right? So because the tile API service was down, for an end user, what did they see? They see a lot of gray tiles, which means the information on the map was not loading, which means the map initialization was failing, and it was all gray because that might have been the default value that the map uses to render, basically whenever it does not have anything. So during this outage, what happened is 65% error rate. That's insane amount of error rate. Directions API P99 response time hit 8.5 seconds and 8500 milliseconds. So that's pretty insane amount of hit that Google Maps took during that outage. And 37% error rate in navigation. So someone using Google Map for navigation, 37% of the requests were resulting in errors. So given the scale of it, you would see how major of an incident was it, right? So the root cause of this incident is actually a feature rollout. In some service, they have not named the service. There happened a feature rollout in a particular, and obviously every single day some of the other developer ships the code, and some feature got rolled out in some service, and that feature and that particular rollout had some bug or something in it, because of which it exhausted the allocated resources on the server. So obviously your service runs on a server has memory disk, CPU, maybe some shared database and whatnot. It exhausted, because of the bug that it had, it exhausted the resources. They have not specified which resource, but obviously it could be one of these four. So shared stateful thing, or CPU or disk or memory. And when something exhausts, like when your server exhausts its resources, and as in your service wants more resource but it is not there. Let's say service needs more RAM but it is not there. What happens? Your process crashes. So that's exactly what happened there also. The service crashed. So as soon as the new feature was rolled out, because it has some bug in it, it exhausted all of the allocated resources and then it crashed. So every time the service was getting up, it immediately consumed all the resources and it crashed. Coming back up, resources crashed. So the services of the processes of this particular service that they have not named continuously kept crashing. Right? Now what happened because of that some service? The core tile rendering service, which renders the tiles on the backend and sends it as a response, that service had a synchronous dependency. On this service on which the new feature was rolled out. Because it had a synchronous dependency and this service had an outage, what happened? Your tile rendering service started getting timeouts because this service was not responding. Let's say your tile rendering service, whenever it was making a call to some service, and we know that in a microservices based architecture, whenever there is a synchronous dependency between two services, it is always great to add timeout to it. So let's say you say that, hey, tile rendering service, whenever it invokes API of this some service, needs to get response within 2 seconds. If it does not get, it would result in a timeout. So that's what tile rendering service did. And because this service was down, the API call made by this tile rendering service always resulted in a timeout. Because it always resulted in a timeout, your tile rendering service, like any other good microservice design does, it retried. Right? So it kept on retrying for that until the timeout of this service hits from the user side or from the customer side it hit, it was retrying. So let's say they hypothetically it retried for 3 times and then it killed off. I'm not getting any response, let me just send a default response to the user. Right. So because tile rendering services resulted in timeouts because of synchronous dependency on a crash service, your tile rendering service started throwing errors. Right. I'll give you an example of how this happens. So let's say your tile rendering service has a timeout of, when your tile rendering service is talking to the some service, has a timeout of 2 seconds and with 3 retries, right? So it would make a call to some service, wait for 2 seconds to get a response and then retry. How many times? 3 times. So the time at which your tile rendering service, like for anyone who is invoking the tile rendering service, for that to get an error, how much time would it take? 2 plus 2 plus 2, 6 seconds. So 2 seconds timeout between these service is equal to 6 second timeout, or 6 second. So it would take 6 seconds for the customer or someone who is invoking this tile rendering service to get an error, because tile rendering service is internally doing this retry. So it all adds up. It is all cumulative thing that would happen because of the timeouts and the retries that you have placed to make your system robust. So now your tile rendering service started throwing timeouts, and because of timeouts, because of retries, it started throwing errors after it exhausted all the retries. And why the errors happened? Obviously that it was not able to get it, but with that retries in place, the internal memory queues of tile rendering services reached capacity. So they might be using, so for what do we use internal memory queues? It could be a small buffer for processing the retried request. It could be a partially baked TCP connection pool, maybe some sort of async behavior that they might want to do within multiple threads. Could be anything. They have not specified it, but obviously whenever you do retry, it has an impact on the code that you need to always validate on what would happen when you go into that state of infinite retries or very large number of retries. So because of retries, the tile rendering service went, it basically reached its capacity and it started crashing because server ran out of memory. That's what I said. As soon as the server runs out of memory, the process that is running, it crashes. And because your tile rendering service crashes, it increased, like, because it crashes, so then it started throwing what? 503, basically service temporarily unavailable. And when server runs out of memory, what happens? So the requests that are partially accepted, right, they would see increased latency. And the increased latency are not just because memory is also, is not just because memory is less, but also because of this synchronous dependency that it had. As I said, 2 seconds of timeout over here with 3 retries is equal to 6 seconds timeout for anyone to realize, hey, this is down or this is impacted. So for every request, you would see increased latency because of retries and timeout. And eventually the request getting rejected by 503. So this is what elevated error rates happened. Then the next part, failure cascade. So you saw how an outage in one service had an impact on another service. Because of it, this service crashed. Now the services that depend on this are which service? The end user service, the Maps SDK, the Gaming SDK, the Directions SDK, right? All of those services, they depend on the tile rendering service synchronously. So, and who invokes Maps SDK? They're either end users like us who invoke Map SDK through our mobile app to talk to that, or some B2B customer who might be using SDK to do some sort of to process their own request or use Google's data for their own needs. So because tile rendering service had an impact, SDK, when it tried to hit the particular endpoint, it started getting increased response time, it started getting timeouts, so that's where it got that gray tile for your as part of your end user. So there might be some users who saw elevated error rates, while some user who saw it like completely down, right? Because there might be some requests that still got accepted, took 10 seconds for execution, the user was waiting for the response, while some connections were not even accepted, so user immediately saw an error out there, right? Here the key part is the customer, the end user customer. This is the most interesting part of this outage. That because of the maps SDK and navigation SDK directly depending on this tile rendering service, the external clients were retrying, as in your device, my device. Internally, it was retrying to get the tile information from the Google Maps API. So, because of that retry, the traffic went 10x. The traffic on the API server of this tile rendering service went 10x. Because earlier, if everything was working fine, you would have gotten response in 2 seconds or 1 second. Now it is taking 6 seconds for it to give you that error. So, because it's all bulking it up, so the total number of API, the total number of concurrent API requests that it is handling shot up to 10x of the normal traffic. Which means that it is putting your service in a, it's basically kind of mimicking a denial of service attack. Not an explicit attack, but an implicit denial of service attack because of the retries that was being done by the end users. And that's going to happen, right? Because it's very hard to differentiate between what a denial of service attack is and what's a genuine traffic and what's a malicious traffic. So because it was a very sudden spike or very sudden jump in the number of requests, a lot of retries put this service in a DOS attack. And because of they doing retries in order to get that information, but that service got overwhelmed by the number of requests that happened, and it basically triggered an entire outage, like an entire crash, an entire set of cascading crashes, right? And that's exactly what happens when you have synchronous dependency as part of your microservices architecture. So here there was a synchronous dependency from user to maps SDK. You can't do much about it. From map SDK to tile, from tile to some service. Because of retries, which grew the traffic to the 10x of the normal levels, your service went into a denial of service. So it thought that it was a denial of service attack, and it started rejecting the request. So when this outage happened, the first remediation thing that anyone would do is rollback. Like, we know that if any latest deployment happened and that and we know that some deployment happened, the first thing that you do is if you can roll back the deployment, you do it right away. And that's exactly what they did. So they roll back the deployment, but because the time for which the rollback was happening, the time for which during that time, the synchronous communication happening between other services was still showing the cascaded error. So the errors on the main service, the sum service got down, it got recovered, but because of the cascading failures that happened, it took some time for other services to recover. So let's say if my first service recovered in, let's say, 30 minutes, it took 1 hour or 1 hour 20 minutes for other services to recover because people were retrying on that, SDKs were retrying on that and whatnot. Right? So it takes time. Whenever there is synchronous dependency and whenever there is this cascaded failure, it's not just the recovery of the core or of the root cause which is important, but also the recovery of all the synchronously dependent component is important. Right? So it took some time for them to recover, and obviously after 2 hours everything got recovered. Error rates were so basically the error rates dropped down and whatnot, and everything was peaceful. So then, as part of prevention, this is where I loved this thing about this particular outage on how Google is planning to basically prevent the outages happening because of the same reason. So the first prevention technique what they're saying is they would want to reject the request when the server is at full capacity. Right, so they mentioned this in the outage document that they would want to reject the request when the server is operating at the full capacity, which means graceful degradation. So instead of accepting the request, making a call to trying to render it, it's always better that if you know that your server is full, do not accept the request at all, and instead immediately return an error to the user that, hey, I'm overwhelmed right now. For example, 429 basically rate limit exceeded or something that suggests the user that, hey, I'm overwhelmed. I'm not going to accept this request unless I have the capacity to do it. So whenever you are putting something into production, see how your system would behave at scale when it gets a lot of inbound requests. Then second is very interesting, where it says that optimize the bounds of server queues. The in-memory server queues of the tiled requests that got bulked up, they said that they would be doing some optimizing of bounds of server queue. As per my guess, it would be around TCP tuning, as in what the number of backlog TCP connections that they would have, web server tuning on the number of concurrent connections your web server would handle, and in-memory process buffer tuning. So if they have allocated a buffer with 1000 as a capacity, maybe they would want to increase or decrease it depending on the dissection that they do internally. The next part is exhaustive monitoring. Obviously, it's always better to get aggressively notified about something. So whenever there is a significant jump in the resource consumption, you would have to be notified about it. So very exhaustive monitoring on all the services. Whenever there is an abrupt jump of resource consumption, it's not the request that has come in, because you might have very small chunk of requests or requests that could be served quickly, but monitoring of your server resources, if basically there is a sudden jump in it, typically due to memory leak or some bad rollout, you should be notified right away. Rather than after your service is gone down, you get notified. It's better to get notified beforehand only. Right? And the final thing, the more important one, is circuit breaking. I love this part about Google on how they said that they would find a way to block internal traffic and continue to serve customers. Which means that on a service that went down, let's say your tile rendering service that got impacted, a lot of SDKs, a lot of internal service might be dependent on it, right? Like, it was not just end users like us who directly depend on the tile rendering service, but also some internal service. So what they said is they would want to find a way through which they can cut off the traffic from the internal services, so that end users like us can continue to use Google Maps seamlessly. So that shows customer obsession of Google on how they are willing to, like, and obviously this is not just basically cutting off all the internal services, but obviously they would classify it into some that these are critical and these are not. By cutting off the traffic that came from the internal traffic while serving the end users is something that is a very solid way of ensuring your end users sees a minimal impact while your internal services suffer to some extent. Right? So always, whenever there is this synchronous dependency, whenever there is this inter-service dependency, try to classify which all are the critical components that needs to serve and which are something that it's okay for them to take a larger hit. Right? And by doing this, what happens? If you cut off the traffic from your internal service, the number of requests being made onto the service would drop down drastically, having more bandwidth to serve your end user facing requests. So thinking about your customers whenever you are architecting your microservices is an excellent way of doing it. Classification of services is something that every single one should be doing while designing a microservice architecture, and have circuit breakers in place. What circuit breakers would do is, it's like a switch where you might, as soon as you turn on the switch, what would happen is, like, the traffic from this internal service would stop coming. So in this context, that would happen. Right? So that's about it. This is exactly what is written in this document. I'll link the outage link in the description down below. Feel free to go through it. It's a very simple one. They have just, like, the things that I explained, it's exactly what they have written. I just tried to read between the lines to understand what could have happened into this. But that's some pretty solid thing that they have done. Like, I love this particular part where they would want to block the internal traffic to their backend servers just to ensure that your end user is not impacted. This clearly shows solid customer obsession. So yeah, that's and this is one diagram that they added into this thing where you can clearly see the number of errors that it got. Basically the overall error rate, it started bulking up. This is where they applied the mitigation, and then it suddenly dropped down and everything recovered after that. Right? So that's typically this particular outage document. Again, I'll link this document in the description down below. So yeah, that's it for this one. Google Map having an outage, not a good thing, but it actually helps us learn a lot of nuances around designing solid, robust microservices based architecture. So I hope you folks learned something new today on designing a robust microservice architecture. And that's it for me for this video. So if you guys like this video, give this video a thumbs up. If you guys like the channel, give this channel a sub. I make 3 engineering videos every week, and I'll see you in the next one. Thanks a ton.